part 3 of lecture 1, week 1. We have some important parameter in communication system which you wanted to explain them. First one is bit rate. What's the bit rate? Bit rate, you know that FB equal to 1 over TB, and bit rate meaning of number of bit per second, number of bit per second, inverse of bit duration. What's the mean number of bit per second? If you have, for example, 10 bit per second, we say that our bit rate is 10 bit per second. So usually the internet speed is represented by bit per second. For example, some companies say that we have 100 bit per second. Some company have 1500 bit per second. In simple word, when the bit per second is increased, it means the speed of the internet is increased. In internet communication system, in other systems, especially in digital system, it represents the same idea. When we have a greater number of bit per second, it means it have higher speed communication system. This parameter is important performance parameter for digital system. When we say 10 gigabyte per second, or we have 0.1 nanosecond bit duration. So we can say in bit duration, also we can say that in bit per second. Industry keeps demanding for higher bit rate due to the user demand. It means when all of the users asking for higher bit rate, so the companies or the industry standard is trying to increase number of bit per second to fulfill the user demands. Another parameter is bandwidth. Bandwidth is, in simple word, is a range of frequencies. Any is a characteristic of information signal or channel medium or devices. In terms of signal, sometimes you have a specific signal. We say that it has a specific bandwidth or requires specific bandwidth. Like for a voice signal, we have 4 to 4 kilohertz bandwidth. In optical channel bandwidth, for example, optical communication, which has a very high bandwidth, we say that we have 118 to 200 terahertz. In some type devices like low pass filter, we say that the bandwidth is from 0 to 500 kilohertz. So it is different representation of the bandwidth, which all of them mean the range of frequency. Bandwidth is related to, B is related to bandwidth. Signal bandwidth depend on the analog or digital modulation format. Different type of modulation sometimes provide different type of or different value of bandwidth, and which are selected based on the desired goal. Bandwidth is valuable resources in communication system. We say that in communication system, we see bandwidth is a very important resource. If you have higher bandwidth, it is better for our company, or it is better for industry parties, which say that we have a higher bandwidth, so it means higher quality in simple words. Another parameter is channel capacity, which is related to the bandwidth. Channel capacity is represented by C, maximum rate for information to be reliably transmitted over a noisy channel. So if you have higher channel capacity, it means it has higher efficiency for sending a signal. We have one formula for it, which is equal to C, channel bandwidth is equal to B log of base 2 in the bracket 1 plus signal to noise ratio. S over N equal to, it is a signal to noise ratio, and B is a bandwidth. So we see that bandwidth and channel capacity is directly proportional. When the bandwidth increases, the channel capacity will be increased. For a given, it is meaning for fixed signal to noise ratio. So for a given signal to noise ratio, channel with higher bandwidth has higher channel capacity. Medium wireless optical link that has larger capacity can support more users. It is very important to understand that when a medium or a channel has a higher or larger capacity, it can support more users. For example, optical fiber, it has very high bandwidth, so it has very high channel capacity. It support multi-users, more and more users compared, for example, to twisted pair wire, which has very limited channel capacity. Now we go to another term, which is a unit measurement in communication system. We say two letter D and B, which we say dB. dB is a decibel, is a unit of measure that quantifies the ratio of two power using the logarithmic scale. Usually dB power is represented in dB, which equal to 10 to log base 10 P2 over P1. For power, we have 10 log, but for voltage, we have 20 log V2 over V1. So in this, P is a linear scale, but P in this dB, we have a logarithmic scale, which is a smaller scale. We have different type of dB. We have dBm, which is related to milliwatt. It has the same meaning of dB, but for smaller power. If a power in milliwatt, if we wanted to represent power in milliwatt, we say that dBm, which dBm equal to 10 log base 10 base of 10 in a bracket power over 1 milliwatt. And we know that milli equal to 10 to power minus 3. Also, for example, 1 milliwatt equal to 0 dBm, and 10 milliwatt equal to 10 dBm, and 100 milliwatt equal to 20 dBm. Also, we can say that dB watt, which is relatively same as the dB, in the denominator we have 1 watt instead of 1 milliwatt. So the output power will be much greater than dBm. So the power in decibel watt, P dB watt, equal to 10 times base 10 logarithm of power in watt. Also, we have dB in volt, which is, as explained before, it means related to the voltage. So the difference is that we have in dBV we have 20 log instead of 10 log. In power we have 10 before the logarithm, but in volt we have 20. Now it's time to ask why we use decibel unit. We have the decibel unit for facilitate calculation and for facilitate representing graphs in communication system. Also, we can show the ratio. We can show the loss, gain, and signal to noise ratio in communication system. We have signal to noise ratio, we have gain, we have loss. These different parameters can be added together or subtracted together more easily mathematically when we use a unit. When we use a decibel unit. Power, in other hand, or in addition, power in the transmitter usually it is very high, or we have huge power in the transmitter, but in the receiver sometimes we have in picowatt. So very high power in transmitter and very low power in transmitter in decibel form can be compare these two together, and easily can be behave with them. Now we go to transmission mode. In communication system, we have different modes of communication. The transmission mode defines the direction of signal flow between two connected devices. When we have two devices, when we have transmitter and receiver, and we have two devices, when they communicate with each other, we have signal three form of signal direction. In simplex mode, signal transmission is in communication is unidirectional. Why unidirectional? Because in one way. In this kind of communication system, for example, we have transmitter from here and we have receiver from here. We always send signal in this direction from TX to RX. Example of this signal is radio system. When the radio transmitter send a signal, our radio at home only receives the signal. We cannot set a signal in opposite direction from RX to TX. In half duplex mode, the communication is two directional, but the channel is in somewhat in the same time can set in one direction. So in half duplex signal, or sorry, in half duplex channel, Sorry, let us do erase this. This signal like walkie-talkie when you have a transmitter and receiver. You can send signal from the transmitter to receiver and from transmitter to receiver, but not in the same time. When we send from transmitter to receiver, we have to uh, wait until the signal is finished, then the RX convert to transmitter and send a signal to other direction. In full duplex mode, which is most of the communication system, the signal can be bidirectional and can be sent at the same time from transmitter to receiver, from receiver to the transmitter. So here's a comparison between them in terms of direction. Some plex is unidirectional, half of the plex is two-dimensional, only one of a time. It means at time we can send in one direction, but in a full duplex we have simultaneously can be send signal in both direction. Send and receive. Sender can only send data. Sender can send receive data at the same time, and sender can send and receive data simultaneously. In performance, you know that is a base for communication systems is one full duplex. It's a most of the communication system are full duplex, like mobile communication system, like internet system, like most of the systems are full duplex, except the simplex form. Sometimes like TV, for this system like TV, satellite, it is a simple duplex, and this one like walkie-talkie, as explained in here. Here's the explanation about transmission modes. Now we have another term as transmission loss. Usually when we send a signal from transmitter and the receiver, a part of the signal will be lost due to the several parameters. The loss of the power or voltage of transmitted wave or current in the passing along transmission line or pass or through the circuit device. So some of the power will be lost in the device, some of the power will be lost in the transmission medium, and some of the power will be lost in the receiving medium. So it means reduction of the power of the signal. In engineering, attenuation is called measured in units. So in this reduction of the power, we say that is attenuation. Attenuation is measured in decibel per unit length. For example, we have 10 dB per centimeter, we have 10 dB or 100 dB per kilometer, which is represent the efficiency of the channel. And it is represented by attenuation coefficient of the medium. Power loss is represented by L equal to P in over P out, which is 1 over G, and G is a gain. Loss equal to 10 log base 10 P in over P out and equal to minus dB. So usually loss will be have a minus value because it is reduce the total amount of power. And also loss can be represented by attenuation constant plus L, where L is the length of the transmission medium and attenuation constant represented by this symbol. And this table show different attenuation for different type of cable. For example, twisted pair cable, which work in different frequencies, has different attenuation. 10 kilohertz has 2 dB per kilometer. For each kilometer has 2 dB loss. When the frequency increases, we see that the loss also increases. Coaxial cable compared to the twisted pair have a lower loss, so it is much better than the twisted pair cable. So at 100 kilohertz has only 1 dB per kilometer, and at 3 megahertz have 4 dB per kilometer. And the rectangular waveguide, which is very good transmission line, but it is bulky. At 10 gigahertz, it has only 10 dB kilometer, which is compared to this value a much smaller attenuation. And the well-known fiber optic cable, which is very important part of communication system nowadays, had a very small losses even in very high frequencies like 1 to 8 10 to power 14 hertz, have only 0.2 dB per kilometer, which is one of the advantage of using fiber optic cable.